wish we could run those labs at 12.
Just kind of resume the recording right here. And I will go over that. Questions 2, 4, and 5 right now. There's some things I think I see that you did. It's really easy to make some simple mistakes on some of these things. And I definitely see some on those. But let's work with number 2 on the quiz here, or the second one, which is going to be if the tractor pulling a sprayer is being checked for a speed in the field and it is 1,250 feet in length, and it takes 2 minutes and 45 seconds to make a pass. What is the speed and travel in miles per hour? So if you think about that lab that we did with the speed lab, this is the same equation that we used, but it's going to be a little bit different. In the equation that we did in lab, we had 100 as our standard in feet. Obviously, we have quite a bit more than that. So we're going to basically input these numbers the same way. What's important to note, because there's really just two sets of numbers that we're dealing with, right? The 1,250 and the 2 minutes and 45 seconds. I'm going to pull up that equation right there for miles per hour. I believe it's on the sheet. I believe I gave you guys this sheet as well. Yeah, right here. So that equation right there, if you take this and we input these numbers, we're going to have that 1,250 that's going to be on the very top. You're going to have the time in minutes all multiplied by 88. That 88 is going to be a constant. So we've got to plug these numbers in. But there's an extra step that you're going to have to do. And this is where a lot on these equations, this is kind of the important thing to kind of like why I wanted to go over these things. And it's a little bit easier to kind of do it, like in person or on like a Zoom call, because, just making a recording, you can't ask those questions, right? Where we can do that. So if I don't clarify it with you, just, send me a message in chat, let me know, and then I can help clarify it. And we are recording it, so that way, anybody else can see this because they may have the same issues. So what we need to do on this is obviously we're going to input, our feed on the top, but the biggest thing is going to be this time in minutes. Okay. And I would assume probably where you went wrong. I'm going to pull this calculator in here. Probably where you went wrong is when you put it in, you may have gone 2.54 minutes, somewhere in that range. And it's not 2.45 minutes. It's 2 minutes and 45 seconds, which is going to give you some different numbers, right? It's gonna change those things slightly. So what we got to make sure is when we're dealing with it, the time said 2 minutes and 45 seconds. I'm just going to go ahead and verify that real quickly. Yeah, 2 minutes and 45 seconds. So what we want to do is we want to take that 45 seconds. We want to divide that by 60. Okay. And this is just something that you have to have that general knowledge from. Where we're going to screw up on these things more often than not is conversions. Maybe not reading the question, correctly, because you guys are going to have the equations. You guys have the equations. When I give you a test on your final, you guys are going to have the equations to work with. I'm not going to pull those things from you, but making sure that we understand how to input them is important. So we take the 45, that's seconds. We divide that by 60 to convert that into minutes. And now we're at 0.75. Okay. So the 45 seconds is actually 0.75 minutes. We can then just add the 2 minutes to that to get 2.75. So what we do is we're going to take that 2.75. We're going to multiply that by the 88, because that's what we have to do on here. Once we have the time in minutes, we multiply it by the 88, and we're going to get 242. So now what we got to do is we're going to clear this thing out, and we're going to take that 1250 that we had on the very top, and we're going to take the 1250 divided by 242. We're going to take 1250 divided by 242, okay, and we're going to get 5.165. We can round up to the nearest 2, 2 points past the decimal. That's typically, kind of where we want to be. On the little quiz that I gave you guys, that stuff is going to be like, I'm going to give you a range there. So on this one, for the miles per hour, what I gave you a range as is if you did 5.1, between 5.1 and 5.2, if you landed anywhere in there, then you're going to get those points. So, and I'm going to give that variance there. So you don't have to be like, oh, it's 5.16, right? And I'm not going to mark it wrong because there's a 5 here, and theoretically would round that up to 5.17. I'm not going to mark you guys off for that kind of stuff. So the range is 5.1 to 5.2. So you went wrong on the conversion from the 45 seconds. You didn't convert that into minutes, then, correct? That's that. Yeah. Okay. So that is like the biggest issue that I noticed with these things, is making sure that we're in the right unit of measurement. That could be true if we're dealing with inches and feet, and you may experience that with some things. If we're talking about like field efficiencies, and we're saying, we're overlapping, in inches, but the equation might be asking for feet. We've got to know that we've got to convert those inches into feet. And if we don't make those conversions, your numbers are going to be completely off. So we'll go ahead and we'll move on into what was that other one? You said you had question 4, which is going to be, yeah, and this one I think I know exactly what you did on this one. So it's a horsepower question. It says what horsepower it should be is. I typed that in wrong. What horsepower is required to pull a 3-shank ripper that has 27,000 pounds of force on each shank traveling at 1.2 miles per hour? Again, we have the equation there. We just basically got to find that. And if you look at these equations down here, we are asking for the horsepower. So we want the drawbar horsepower. We don't want draft. Draft would be if we know the drawbar power and we know the speed of the tractor, then we're going to do that. But we don't. We know the force in pounds and we know the speed of the tractor. So this is going to be the equation that we're going to be working with. Again, that 375, we kind of talked about that based on how much horsepower is there. You guys don't need to know that. You don't need to remember that. You're going to have this equation, right? So that 375, just understand that's a constant, right? And so all we got to do is we've got to apply these things into there. What I would assume that you did is that you took the 27,000 pounds of force, you times that by, let me see here, 27,000 pounds of force, you times it by the 1.2 miles per hour that the tractor is going. You get 32,400. You divide that by your 375, and you're going to get 86.4. And that's exactly the answer that I see on your sheet there. Where we kind of missed this thing is that it's 27,000. I'm going to go back to this thing here. It's 27,000 pounds of force on each shank. Okay, so each shank is producing that amount of force. So what you got to make sure that you do is that you take that 27,000 times that by 3, because there are 3 shanks on this ripper here. And then the total force of that piece of equipment is 81,000 pounds, right? For the 3 shanks, it's 81,000 pounds. We can then multiply that by the speed that we're going, which is 1.2. That's going to give us a total of 97.2 pounds of force. Divide that by 375. That's that constant that's in there. And then we're going to end up getting 259.2. So as long as you kind of do these numbers right, again, the answers that I gave you in between, 258 to 260. Sometimes, especially if we're having to round and do that kind of stuff, those numbers can change slightly. So that's why I give you guys a little bit more of a range there. If you don't multiply that by the force, because maybe we just overlooked that on that question, and you don't multiply it by 3 shanks there, your numbers are going to be so far off, they're not going to be within that stuff there. Okay. So it's good. It's good that we have that. It's good that and that's why I wanted to give you guys this quiz. And I believe I opened this up to basically take these quizzes again. Because the idea is not to hinder you guys. It's to prepare you guys for this test. It's to prepare you guys kind of for that final And at that point, we'll have very similar questions to this stuff. Numbers are going to be different. We might have 5 shanks instead of 3 shanks. The pounds are going to change. The miles per hour are going to change. But the general concepts are going to be the same, and they're going to be asked in a very, very similar manner. They might be the exact same manner without the grammar issues that I have in those ones. So it's an easy mistake to make, right? And lots of people do that, but it's good to make those mistakes now, so that way we can kind of cover it and learn it. If this quiz is not opened up, and this is for everybody, if you're going to watch this recording later on, you can just retake that quiz and try to get that 100% on there, because it will count for points for you. But I think I have it like 5 times you can retake this quiz to get it there. So the idea is to get you guys all the points on there, get you that practice into this stuff. And I'll probably throw some more questions out at you, maybe even next week, kind of do some other questions, because I don't know if this covers necessarily everything. All right, okay, cool. So I do have it set up with the quiz to take it multiple times. So feel free to do that. I don't know if it closes today or not. I can maybe expand that out and allow you guys to take it more time, or expand the time that you guys can take this. So number 5, time to complete the field. It's how many hours would it take to disc 350 acres traveling at 5 miles per hour with a 21-foot offset disc with a 92% efficiency? So this one is kind of like it's kind of a 2-step kind of process here. And some of it we don't actually have an equation for, just because we don't necessarily need an equation. But for this portion right here, right, when we're dealing with that 5 miles per hour, 21 offset foot disc at a 92% efficiency, we're going to be grabbing not our theoretical field capacity. We're going to want our effective field capacity, which is, this equation is messed up. I thought I had a different sheet that was a little bit cleaner than this one. So on our theoretical field capacity, we basically don't have that percentage in there. On the effective field capacity, we basically have that time. It's basically the same exact equation. And I believe I gave you guys a different one because this one is a little bit messed up. But basically what we have is our efficiency percentage, right? Our efficiency percentage is going to be multiplied on to the end of this, and it's all going to be divided by 8.25. Because our theoretical field capacity doesn't have like the turns and all that kind of stuff in there. So it's really the same equation as our theoretical field capacity. We're just adding in that efficiency percentage. So we're saying that we're at a 92% efficiency, meaning that we're going to be making our turns. We're going to have those types of things where we're going to drop our efficiency. Yeah, so we're going to input those numbers on this one and see how those run. So on this one, we have 5 miles per hour. So we're going to input that 5 miles per hour. Our implement width is 21 feet, okay, and that is in feet on the question, and it's in feet on here, so we don't have to do any conversions there, so we're good. And then we get 92% efficiency. So we'll just input those numbers, and we'll go from there. So 5 miles per hour times the 21 feet that we have times, now this is kind of important, okay, because it is a 92% efficiency. Meaning we're going to multiply this not by 92, we're going to multiply it by 0.92. And the reason for that is if it's a 92% efficiency, we're not multiplying this thing by a percentage unless your calculator can do that. So if we say 92, oh, that doesn't work on this one. Yeah, let's go percent 92. I don't know if that's going to work. Sometimes they have the percentage. To me, I don't even mess with that really. All I'm going to do is take that 92, divide it by 100 to convert this into a decimal form, which is going to be a portion of that 100%. Okay, so it's always going to be 0.92. Just move that decimal over 2 points. A lot of times you don't even need to do that in your head. Again, just kind of do it visually. It's pretty easy. But if you need to do that to convert it to make sure you have it right, by all means, take the time on the math to do it right. Make sure you know, that way you get the right answer. So we'll run these numbers again. It's 5 miles per hour. It's a 21-foot disc. It's going to get 105. You're going to multiply that by 0.92. So you're going to get a portion of that 105 because we have inefficiencies in the field. That's naturally going to happen. You're never going to be at 100% because of time to travel, turns, overlap, whatever. So we're going to get 96.6 on there. We're now going to take that and we're going to divide that by your constant, which is the 8.25. And then we're going to end up getting an 11.70. Okay. Now, what that number is, that is how many acres per hour that we are going to spend, like how many acres we can get done in 1 hour is 11.7. Now, there's another part to this that we need to kind of make sure we're kind of thinking of. We'll pull these both up here. Okay, this question is asking how many hours would it take to disc a 350 acre field at those numbers there. Okay, so we figured out using that, the effective field capacity, that we can do an 11.709 acres per hour. Okay, what we want to do is take that number. I'm gonna kind of memorize. I'm probably gonna round this up because this is a long number. We've got a 9 there. I'm gonna go 11.71, but I'm gonna have to clear these things, and I'm gonna take that 350 acres that we have, and I'm gonna divide that by the 11.71, and we're gonna get 29.88. Again, if you go 2 decimal points, it's going to change those things, but it's going to really change some of these numbers. If I didn't put that full number in there, it's going to change these things back here. The range I gave you guys on this was 29 to 31 because it doesn't matter how much you go. Even if we were to do this, I think if we didn't take the decimal, because what I go 11.71, if you did like 1 point past the decimal, right, we'll go 350 divided by 11.7. I'm still going to get 29.9. I'm still going to be within that range. I gave you 29 to 31. If you did 350 and you divided it out by only 11, that might change that number. It's going to put us out. So you got to make sure you use the decimals if they're there, because that would put us at 31. And the highest that I gave you guys on that was 31. So it's kind of like that 2-part thing, right? Where you've got to figure out how many acres you can do in an hour. Then you've got to take that field and divide how many acres you're going to get done in that hour, and divide those things there. Use an incorrect formula for number 5. Okay, I tried working on it several different ways, still couldn't figure it out. All right, perfect. Well, I'm glad that has helped you then, and kind of made sense. The biggest thing, and kind of between, just for like everybody else here, when we're dealing with theoretical field capacity versus effective field capacity, they are essentially the same exact equation minus this efficiency percentage there. So if it's asking you, or if the equation is going to give you those things and we're asking for that theoretical field capacity, this one doesn't actually state it, but we just got to know, because if we're going to plan how long a field's going to take, we're not using theoretical field capacity. We can use our theoretical field capacity and our actual time that we drove to figure out what our efficiency is. So if you are going through a field, you can say, I'm going to use the theoretical field capacity formula to figure out how long it would take without any turns. If you were just constantly going, the machine's never being lifted up, and then you run through a field and it takes you X amount of hours, that's where you're going to use to figure out what your efficiency was. Once you kind of have a general idea of like, look, I'm disking a field, and you do it all the time, you're going to know generally, hey, we're at a 92% efficiency, and you can apply those to something that is unknown to figure out how long it's going to take you. And if you want to figure out like pricing and things like that, that's going to help you, because the time that you're going to spend in that field is going to help you price it. If you're doing custom, disking for somebody, it's going to help you determine the pricing that is necessary, because you're going to be pretty close on how long it's going to take you to get through a field. Some things like irregularities in the field can cause a big issue if you have to make more turns than just a standard square field. How long the runs are, those things are going to vary a little bit, but with experience we get better, and we kind of know generally where those things are at, and so that's kind of why we would use a theoretical field capacity versus an effective field capacity. But in that case, that's what we're doing. Cool. All right. And nobody else has jumped in. We've answered those questions. So I'm assuming that everybody else is probably going to be okay. If anybody is watching this and you guys want me to kind of work with you, I can set you guys up with it. You guys can kind of meet with me. We can do it on Zoom. And I can kind of help answer some questions. Next week, I'll probably throw some more out there to kind of keep these things fresh in your guys' mind. Yeah, you're good to jump off, Thomas. Yeah, so we'll keep this stuff fresh in your guys' minds and keep these things in here. But if you have anything, if this thing didn't help maybe answer some of your questions, then just shoot me an email and we can work with it. I know this may not work with everybody, so if I can do it at a different time and help you out, just let me know. All right, I'll see you guys later.